And back to our warm attacks on NPM and this Shai Hulud risk. In this part, we will take a look at how to check your node project, so whether it be React or whatever, Node Express, anything that essentially uses node modules for any known affected packages. So just like in the previous one, you will need a little tool. You can clone it from the GitHub account, which will be in the description as well. So let's grab that first. That's here. There's a README. I do make spelling mistakes in README, but it seems like it's more or less spelling mistake free. All we need to do is grab this. So this is going to be the clone. This is just a suggestion to which folder you want to clone it to. I guess we'll go with that. I'll open up my terminal. Again, it will work either on Linux or a Mac. In fact, this part is a lot simpler than the extensions check, because with node modules, the actual check is much faster and simpler, because we can reference that package JSON. Stay put for later to see how it actually works if you're interested. So anyhow, let's clone this. I'll just cd into projects, and I will clone from this repository. I guess I'll name the folder something else. So projects, and I'll name it node check. You can name it, you can literally name it whatever you want. And let's go into node check. We can open it up and take a look at it. It's the philosophy is similar to the VS Code extensions. The VS Code extensions check. We have a list of all of the known so far compromised packages. Again, NPM is very good about removing these. So if you're using a well-known package on the latest version, chances are it's already fixed. But just in case you have a project and you're worried that one of the older packages might be in there, this is how we will check. So anyhow, we have this node sh check. That is our shell file. So let's go in here. Let's list that. So first we will need to make this executable. Again, it's in the README in the instructions. So I will chmod and then +x, and we want to make this part executable. So we'll have that, and now it's executable. Now this time, unlike the VS Code extensions check, we actually need to point it to the directory of a project we want to check. So what I mean by that, let me open up a different tab, and let's say in my projects folder, I have which, let's see, games API, I think. Yeah, I have a project which uses Node, and it has a Node modules folder right here. It's some sort of a server for simple board games, and I want to check that. So here is my directory, or I can get directory like so. Either will work with this tilde, or like the full directory. Really up to you. I'll grab the actual directory, and I will do the following: node execute node sh, and then the argument is going to be which project directory I want to check. So I'm not going to say /node modules, because the program itself essentially knows to look into node modules, but it needs to know where to go. So it's going to go into my projects directory, games API backend, and backend verso. And we will press OK. And basically it will check literally every possible node module that is installed in that folder, and it will either say okay or will give you a warning if it's suspect. And then if it is suspect, you will have it in the compromise report CSV, and then you can remove it. You have some directions on how to remove it in the README. If you open up the README, let's go back to the README. Basically, we can uninstall the package name and we can install a latest safe alternative. And then just to be safe, we can cache clean with npm cache clean force or yarn or pnpm commands if you use those. All right, so assuming that you are running this and everything comes up okay, then this is fine. But what happens if something, if essentially a package shows up as problematic? Well, actually, let's kind of simulate this. I'm gonna mess with this txt file, but it's essentially to show how the program might show a bad package. And let's simulate what happens if this program will find a dangerous or compromised package. Well, I'm not going to install a a compromised package, but we can simulate this with like a fake compromise package. So what I'm gonna do is go to, I think I have this prepared, and this demo app basically has a node modules package, the JSON and whatnot, and within node modules I have a fake module which is not a real npm package, but for all given purposes this program will treat it like it is a real npm package. And there's a version of this fake module. If we take a look in here, and this version is 1.2.3, very, very creative. So what we will have is we will add, don't do that, this is just for demonstration purposes. I will have a fake module at 1.2.3. So I'm telling the program essentially, hey, also look for this version 1.2.3, and the so-called compromise package is called fake module. And now if I run this tool again, where do we have that? So before we were running it on this directory, we will run this on this demo app directory. And again, I can either use this directory or I can use the full one. The script will recognize either or. So let's run this and point this to demo app, just demo app, not the node modules, because it will find the node modules itself. And let's see what happens. Okay, so it went through all of these, and now it says working on fake module at 123, and it has a warning, right? And it said, oh, hey, found something, scanned this many packages, found this compromise package and saved it to compromise report.csv. You can open it up with VS Code, you can open it up with any text editor, and I will open this up. And now we have this fake module 123, version 123 is compromised. And in this case, I would go and follow the directions. If this was a real npm package, the directions are here. So I would do npm uninstall. For example, I would say npm uninstall, and then that fake module. And then I would clean the cache and, for example, install a newer version of this, for example, fake module. And well, essentially that would be it. And of course, rotate my Git credentials or any other tokens that I might be using for other hosting services, cloud services, and whatnot. So again, no need to freak out. All that needs to be done is that. And another thing that I wanted to quickly go over is some of these directions, what we have in the README. What this npm ls means. You might have seen this, you might not have seen this, but it will help you. It will help you find. Let's say it finds a compromised package. Whatever. Let's say it's going to be. Let's remove this fake module. Let's say it's going to be this I don't know, Amber Velcro version 2.22. And it finds it and it throws it into the compromise report, essentially. Now, there's a way to figure out which libraries, which packages use that package, essentially, because this might be used by, for example, another node module. And what do I mean by that? So let's take a look back at our safe whatever games API backend Vercel. And let's take a look at our package.json. So this is essentially extra if you're interested in understanding how a lot of these things work. Okay, so I have Express, right? Seems like I only have a few dependencies here. It's bcrypt, body parser, cookie session cores, .env, express, mongoose, and so on. So however many, like 8 of them. However, right, if I go here and I change into node modules, and I list all of these node modules, oh my god, I have a lot of node modules here, and certainly more than 8, right? We have something like encode URL. Let's say this encode URL, this package shows up as a compromised one, and you're thinking, wait, hold on, I don't have this in my package.json. What do you mean encode URL? Because I'm not even using this dependency. But you can figure out which package is using this dependency, because if we go npm ls and then encode URL, npm will give you a nice, tree, I suppose, to show which packages are using encode URL. Well, we have this, Big Daddy package Express, and it uses encode URL, and within it, some final handler is also using encode URL. Within it, send at 1.2.20 also uses encode URL, and then serve static also uses encode URL. So in this case, for example, you would essentially, uninstall Express, assuming something like this would be affected. A package like Express is very good about using updated versions or not having big problems like these. But in case, for example, we have a package like encode URL which is affected, this command will give you essentially a nice visualization of all of the packages which use that specific package. So in this case, uninstalling Express and updating it to, let's say, a newer version would fix that for you. Or if, let's say, Express and, let's say, bcrypt would be both using encode URL, this would show you that Express is using it and bcrypt is using it as well. And that's all there is to it. Again, no need to panic. It's just part of everyday life. And stay tuned. Maybe there'll be another one where I'll kind of go into details on how some of this works behind the scenes.